Welcome to Scale Up University. Welcome to the course on Power Plant Engineering. So this is the lecture 3 of module 1, classification of power plants. So in this lecture, we will be discussing classification of power plants. Now, before classifying power plants, one very important question in front of us, why do we have different types of power plants? Because ultimately we have to generate electricity. So why there are different types of power plants? So first let us understand that. So if I talk about electric power, so the electric power demand is not uniform. Electric power demand, it varies with time. Like day and night, it might be different. In the night time, the demand might fall. In the daytime, the demand might be high. It also depends on the seasons. Like in the summers, because of like air conditioners, the demand might be very high. So electric power demand, it is not uniform. It varies with time. It even varies with location, because in urban, the demand will be very high as compared to rural. So electric power demand is not uniform. It varies with time, it varies with location, and it also varies with the application. Like in industrial, demand will be very, very high as compared to domestic electric power demand. Since the electric power demand is variable, it's not uniform, and hence we cannot have a single power plant. So no single power plant type. So we cannot think of a single power plant type which can meet all the load conditions. So for different load conditions, we certainly need different types of power plants. We cannot have a single power plant type that can minimize cost and maximize reliability. So hence, power plants are classified so that the right plant is used for the right purpose. And this is the objective of this lecture. Now you got a very good understanding that why there are different types of power plants are there. And in this lecture, we will be doing the classification of power plants. We'll be classifying all important power plants. So if we look at the topics that we will cover in this lecture, so we'll discuss thermal power plants, nuclear power plants, hydraulic or hydroelectric power plants, gas turbine power plants, diesel power plants, cogeneration plants, combined cycle power plants, and comparative over. And then we will conclude this lecture by the comparative overview of power plant types, wherein we will be comparing all popular power plant types. So all these topics we will cover in this lecture one by one. So this is the module 1, economics of power generation, lecture 3, classification of power plants. And we are starting with the first topic of this lecture, thermal power plants. So as the name suggests, thermal power plants has to do something with the heat, because thermal means heat. So how it works, so the basic concept, if we try to understand of thermal power plants, so it involves burning of fossil fuels like coal, oil, or gas. And when we burn the fossil fuel, heat will get generated, and that heat will basically boil the water. Steam will be generated, and that steam will be responsible for turbine, rotating turbine. And when the turbine will rotate, electromagnetic induction, because of electromagnetic induction, electricity will get generated. So we will get electricity as the end product. So this is how the thermal power plant works. Now, if I talk about the key characteristics of thermal power plants, so we have large installed capacity, continuous operation, because thermal power plants, they can operate continuously. So hence they are used as base load power plants. They have large installed capacity. It is a mature technology, because all the globally also, if you look at uh, one of the most important power plant is a thermal power plant, and it is suitable for base load. If we discuss the advantages of thermal power plants. So they are located near fuel sources. They're proven and reliable, high power output, and they're suitable for large grids. And if we talk about the limitations of thermal power plants, high fuel consumption, because in order to generate heat, we have to burn fossil fuels. So it consumes high fuel. Environmental pollution, because of burning of fossil fuels, it emits gases like carbon dioxide, sulfur, oxides of sulfur and nitrogen, which are harmful for environment, which can cause environmental pollution. So thermal power plants, they basically cause environmental pollution, large water requirement, because we heat the water to generate steam, so large water requirement will be there. And when we talk about efficiency, it is it has lower efficiency because multiple conversions are involved, and in every conversion step there is a loss of energy. There is a loss of energy. If we talk about the role in power systems, so the role of thermal power plant, so they form the backbone of electricity generation globally. So globally, thermal power plants, they act like the black backbone of electricity generation. They are still so dominant despite limitations. So this was thermal power plant. Now we will look at nuclear power plants. So if we look into the basic concept and flow of a nuclear power plant, so nuclear fission in a controlled manner, a nuclear reaction takes place, the fission reaction in a controlled manner, it will generate huge energy, and that will be used to produce steam, and that steam will rotate the turbine, and this turbine generator, so the steam will drive this turbine generator system, which will produce electricity. So this is the basic concept of nuclear power plant. If I talk about key characteristics, before that, one very important point, nuclear power plants, they have like very high fuel energy density. So fuel energy density is very high. It means a very small quantity of fuel can generate a very large amount of electricity. And hence we say that fuel energy density is extremely high, because certain grams of nuclear reactants participating in the nuclear fission reaction, they can generate enormous energy, and we can generate very large amount of electricity. So that's why fuel energy density is extremely high in nuclear power plants. If we talk about the key characteristics of nuclear power plants, so very high capital cost, extremely high capital cost, low fuel cost, continuous operation, it can operate continuously, and high capacity factor, it can generate large amount of electric power. So these are the key characteristics. If we talk about the advantages of nuclear power plants, large power output, like a small fuel quantity can produce large power. No combustion gases. So this is a very interesting and important application or advantage, since here no burning of fossil fuel is involved. So it is like a clean form of power generation. It is a clean form of power generation, and it is suitable for long-term base load because it can operate continuously generating large amount of electricity. So it is suitable for long-term base load. If we talk about the limitations of nuclear power plants, high initial investment, radiation safety concerns. Since nuclear reactants are involved, radiation safety is a very big concern in front of us. Long gestation period and complex waste disposal. So disposing is, because here nuclear waste will be generated and we cannot dump it anywhere, because we know that nuclear radiation is so harmful. So waste disposal in itself is a challenge. for nuclear power plants. If we talk about role in power system, so in power generation system, these nuclear power plants, they act like base load plant. Long term stable demand they can serve. So they are used when constant supply is needed. So that is nuclear power plants. Now we will discuss hydraulic or hydroelectric power plants. So if we talk about the basic concept of hydroelectric power plant, so hydroelectric power plants, they convert potential energy of stored water or kinetic energy of flowing water into electrical energy using turbines. So in hydroelectric power plant, either the stored water, the potential energy of the stored water or the kinetic energy of the flowing water, it is responsible for rotating the turbine. So the turbine generator will generate the electricity. So that is how the electricity is generated in a hydroelectric power plant. If we talk about the key characteristics, here the energy source is renewable because here the energy source is water, and water is, we know that, renewable because of the rain. We keep on getting water. Water can be renewed. No fuel cost is involved because water freely available. High efficiency because here heat energy is not involved. So losses will be very less. So this is a very important point. If you want to compare thermal power plant and hydroelectric power plant in terms of efficiency, hydroelectric power plant is more efficient because here the fuel is the water and no need for us to heat it. So no conversion will be taking place. No need for us to generate steam and all that. So hydroelectric power plants are very much efficient, high efficiency, and quick response to load changes. They quickly respond to load changes. If we talk about the advantages of hydroelectric power plants, clean and pollution free, low operating cost, long service life, excellent for peak load operation. And if we talk about limitations of hydroelectric power plants, high initial civil construction cost, site specific, because we can set up only near water sources, flowing water. They are affected by rainfall and seasonal variation, environmental and rehabilitation issues. And if we talk about role in power systems, so this hydroelectric power plant, they are used for peak load, load regulation, and they are used as emergency reserve. They are used as emergency reserve. Now we look into gas turbine power plants. So if we look into the basic concept of gas turbine power plants, so here uh, fuel combustion will generate hot gases. So hot gases via fuel combustion. So this hot gases. So the idea is that first we will burn the fuel, hot gases will be generated, then we will directly open the nozzle. So these hot gases, they will expand in a chamber containing turbine, and turbine will rotate, and the mechanical energy of that rotation is converted into electrical energy. So this is how the gas turbine power plant work, wherein burning of fossil fuel, it will generate hot gases. Those hot gases, when they expand, they will have kinetic energy. They will rotate the turbine, and the rotating turbine, the mechanical energy will get converted into electrical energy via generator. So this is how gas turbine power plants work. If we talk about key characteristics of gas turbine power plants, compact size, quick start and stop, simple layout. If we talk about advantages of gas turbine power plants, low capital cost because they're compact in size, fast commissioning, very easily we can set up, peak load suitable, they're very much suitable for handling peak load, and low water requirement because here no steam is involved. Directly the gas we are using, the hot gas. If we talk about the limitations of gas turbine power plants, so here fossil fuel will play a role. So high fuel cost, lower efficiency, because wherever heat is involved, efficiency will be low because here heat is involved. So uh, heat will escape. It will get converted into other forms. So low efficiency and performance affected by ambient temperature, like the outside temperature, it might affect because it is based on the concept of expansion of gas, and expansion of gas, it not only depends on the temperature of the gas but also the surrounding. If the surrounding temperature is high, then it will affect the ambient temperature affects the performance of gas turbine power plants. If we talk about role in power systems, so gas turbine power plants, they are primarily used as peak load plants, or they are used as standby emergency plants. Standby emergency plants. Diesel power plants. If we look at the basic concept of diesel power plants, how it works. So diesel power plants, they make use of internal combustion engines wherein we add the diesel, diesel will burn, combustion will happen, and that internal combustion engine will have a mechanical output, and that mechanical output directly drives the generator, which will generate the electricity. That's the idea of diesel power plants. If we talk about the key characteristics of diesel power plants, small capacity units, kilowatt to few megawatt, decentralized operation, it is not at all dependent on grid, and very simple installation. It is very modular and portable. Now, I hope it is making sense that why it is decentralized, because simple generators you might have seen in your surrounding also. Like many people in their house, they use generators, or in some office buildings, you might have seen generator wherein we fill the fuel, the diesel, and when we run it, it will generate the electricity. Now, if we talk about the advantages of diesel power plants, quick starting, like we can start it in minutes, low initial cost, relatively very low initial cost, suitable for remote areas, islands, deserts, high reliability for small loads. For small loads, steady output, it is a perfect choice. If we talk about limitations, high fuel cost, because diesel is involved. Now the price of the diesel, it keeps on fluctuating. High maintenance, moving parts, oil, maintenance is required. We have to maintain the generator. Noise and vibration, it requires isolation because this generator, it generates noise also. And it is not suitable for continuous large scale generation. It is inefficient for long term. Long term, we cannot use it. And for large scale generation, because very like a large quantity of fuel will be needed, then economics will it will be very expensive then. So it is not suitable for large scale. It is suitable for small loads, for steady output, not for continuous output. And if we talk about the role in power system, role of diesel power plants in power systems, so they are used for standby power, backup for outages, emergency supply in critical facilities, isolated locations. Okay, so it is used in isolated locations like off-grid communities, like a remote village, a remote area where grid is not there. There we can make use of it. Generators in emergency supply, we can make use of it. It can be used as a standby power. Cogeneration plants. So they are also called as CHP plants. If we talk about the basic concept of cogeneration plants, so they are basically combined heat, combined heat and power plant. What it means is that, what is the meaning of combined heat and power plant? This cogeneration power plants, they make use of waste heat. They simultaneously utilize waste heat. Now, what is waste heat? We know that in a thermal power plant or in a gas turbine power plants, heat energy is used. So wherever we are burning the fossil fuel, heat energy will be generated. A part of that heat energy will be used in either boiling the water, generating the steam, or heating the gases. Now, a very good amount of heat it gets wasted. So in cogeneration plant, what we are doing is that in a already running plant, whatever the heat which we call it like the waste heat, we are further utilizing it. So we utilize the waste heat for process heating, space heating, and for heating water. So this is a very powerful concept wherein the waste heat, instead of just letting it go, we are utilizing it for process heating, space heating, and hot water for heating water, which will further, because if we utilize that waste heat for heating water, that hot water will generate steam, which will further generate electricity without us for burning additional fuel. So without uh, burning additional fuel, we are able to generate electricity by utilizing the waste heat. So that's a very powerful concept of cogeneration power plants, wherein we are utilizing the waste heat to generate further electricity. If we talk about the key characteristics, they have high overall efficiency. Efficiency is increased now because waste heat we are utilizing it. Industrial integration, they are these cogeneration power plants, they are integrated with an already running power plant. So that is what we call it like industrial integration. And they reduce energy wastage. If we talk about the advantages of cogeneration power plants, improved fuel utilization, lower operating cost, reduced emissions, suitable for industries with heat demand. And one more very interesting thing, in any industry where heat is getting generated, in any industry where heat is getting generated, what they are doing is that once the chemical process is accomplished, they just waste the heat. Now we can make use of that waste heat also to generate electricity. And there also this cogeneration power plant will play a role. So cogeneration power plants, they are integrated with the industries which make use of heat, which generates lots of heat. So these power plants are suitable with for industries with high demand. And the best thing about cogeneration power plants is that no need for us to burn the fuel, no need for us to burn fossil fuels. We can directly utilize the waste heat coming out from industries. If we talk about limitations of cogeneration power plants, now load matching is a problem. So load matching between heat and power required, because here we are dependent on the waste heat. Now, if the load is high and the waste heat generated is very less, then it's a limitation in front of us. Then we cannot fulfill the load. So load matching is always a challenge, and it is location specific, wherein we cannot set up cogeneration power plants independently. We have to integrate it with industries. If we talk about role in power systems, so they are used in refineries where heat is being used, chemical plants, paper and sugar industries. So these are the places where cogeneration power plants are used. Combined cycle power plants. So if we talk about the basic concept of combined cycle power plants, how they work. Now they work, the mechanism is like we already have a, like, let us suppose a gas turbine power plant. Now in that gas turbine power plant, we burn the fossil fuel, it will generate the heat that will make hot gases. Now that hot gases, they will expand, they will rotate the turbine, and excess exhaust gas will contain heat. We call it the waste heat. So gas turbine is already generating power, but it is also supplying exhaust gas as waste heat. And in combined cycle power plants, we make use of this waste heat. So there is a heat recovery system which will recover the heat, and it will just boil the water. So heat recovery steam generator. So heat recovery steam generator, it will capture the waste heat and it will generate steam. And the steam turbine, so one steam turbine will be there, it will generate additional power. So this is the combined cycle power plants. So see, so effective it is. So here gas turbine we use for power generation. Waste heat from gas turbines, we use it to produce steam, and steam turbine will produce additional power. So this is how combined cycle power plants they work. If I talk about key features, so here basically two cycles are working simultaneously. So we have Brayton cycle for the gas, wherein what we are doing is we are first compressing the gas, then the combustor, it is making it hot. Then we are rotating the gas turbine, the hot gas, it is rotating the turbine. Now the excess heat generated is supplied to the other system which operates on the principle of Rankine cycle. So here we make use of a heat recovery steam generator. It's a boiler actually. So whatever the waste heat we had from the gas turbine, the exhaust gas in the form of exhaust gas, we are making use of that. We are supplying it in the heat recovery steam generator, the boiler. It will generate the steam, and that steam what it will do, it will rotate the turbine. Now once again what we are doing, the excess heat, the waste heat in the form of steam, we are capturing it and we are condensing it. We are getting water out of it. Then we are compressing it, pump. Then we are pumping it in a boiler. So that once again will generate steam. So this is very interesting. And in the previous cycle also, whatever waste heat we are generating, a part of it we are giving it to the HRSG, and a part of it we are also compressing it, utilizing it. So a cycle is there. So two cycles, they are working in sync. And now we can see the efficiency, very much higher efficiency than simple thermal power plants. So they are very much like highly efficient than simple thermal power plants, because now we are making use of the waste heat from the gas turbine. We are compressing it and reusing it in the Breton cycle, and also a part of it we are supplying it to the other process, the Rankine cycle, wherein that exhaust gas, the hot gas, it will be used in the boiler to boil water, to generate steam. That steam will rotate the turbine, and the excess of steam, the waste steam, we will condense it, we will convert it into water, and and supply that water into the boiler. And boiler is getting heated with the excess heat, waste heat from the previous process. So no need for us to burn any fuel, additional fuel. So that's how it works. If we talk about importance and outlook, definitely you can say that improved fuel economy, that's very evident, lower emissions, and it is very increasingly popular in modern power systems. In modern power systems, combined cycle power plants are becoming very popular. Now we'll discuss comparative overview of power plant types, wherein we will be comparing all different types of power plants in terms of capital cost, in terms of operating cost, in terms of efficiency, in terms of load type, and in terms of flexibility. If we talk about thermal power plant, just focus on the thermal power plant, or let us do one thing. Let us take one feature at a time. Let us take one feature. So let us just talk about capital cost and compare it for all different types of power plant. So for thermal power plant, capital cost is high. For nuclear, it is very high. For hydro, it is very high. For gas turbine, it is low. For diesel, it is low. For cogeneration, it is medium. And for combined cycle, it is medium. If we talk about operating cost, capital cost means one-time setup cost. Operating cost means running cost. For thermal, it is medium. For nuclear, it is very low. Because see, operating cost, one major cost is the fuel cost. In nuclear, we know that very little fuel can generate enormous energy. So that's why the operating cost is very low. In hydro, it is even low because the primary source, the water, is freely available. For gas turbine, it is high because uh, burning of fossil fuel is involved. For diesel, it is very high because diesel is very expensive. For cogeneration, it is low, and for combined cycle, it is medium. In cogeneration, it is low because we are not at all burning any fuel, rather, the heat generated from industries, we are making use of that heat. If we talk about efficiency, thermal, it is medium, nuclear, it is medium, hydro, it is very high efficiency because no heat is involved, losses will be less. Gas turbine efficiency will be very low. Diesel, it will be very low. For cogeneration, it is very high because we are not at all burning any fuel. We are utilizing the waste heat of other industries. And for combined cycle also, it is very high because whatever the waste heat we get in the form of exhaust gas, we are making use of that. Now, in terms of load type, if you talk about thermal, uh, they are mainly used for base load. Nuclear also base load. Hydro, we can make use it as peak load and base load. Gas turbine, peak load. Diesel, we make use for steady supply for emergency. Cogeneration, it is for industrial use. Combined cycle, we can use it like a base load and intermediate load. If we talk about flexibility, so thermal, low flexibility, nuclear, very low flexibility, hydro, very high flexibility. High flexibility. Flexibility means changes in the operating procedure. Now, thermal is like rigid. Nuclear is very rigid. Hydro is some sort of flexible. Gas turbine is very flexible because it is very small and low capital cost is involved. Diesel is very high flexible. We can carry the diesel generator with us. Cogeneration, the flexibility is medium, and combined cycle, the flexibility is medium. So finally, we completed this lecture. So in this lecture, we saw that a modern power system, it is never based on a single type of a power plant. Instead, it's a mix. The purpose is to minimize the cost, maximize the reliability, and to meet the environment constraints. So in this lecture, we classified different types of power plants. We understood their operating principles, how different types of power plants they operate, the mechanism, the basic concept behind them. We compared all the different types of power plants, their advantages and limitations. And we also linked power plant to load characteristics. So I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.